Hello, I promise you will never get confused again in solving any certain circuit given to you to use Kirchoff's current and Kirchoff's voltage law. But before going into any solution, let me give you the simple steps to follow. Let's first solve this simple circuit having one loop. And the process here is, obviously, sometimes circuits are given without any sign convention. So the first step here is, keep in mind always that current flows from the positive terminal to the negative terminal of a given battery. Now here always knows that positive terminal is where the long terminal of a battery is, then assign positive here. And the negative terminal is always where the small terminal is, assign negative there. So, you know, current always flows from positive direction of the terminal to negative direction of the terminal. And now the second step here is, what should we use in this ohm resistor and this resistor? Are we going to use negative to positive or positive to negative? What to do here is, always current flows from positive, therefore it starts to enter into a resistor from positive terminal to negative. But note that resistor has no any terminal. This sign shows that this current always starts entering where it is positive to where it is negative. So this current, let's see, I1 keeps flowing. It enters into 5 ohm resistor. It will move out and enter into 10 ohm resistor. Still, I1 will enter into 10 ohm resistor. And from where? From positive to negative. So now you can choose. Are you going to take this loop into clockwise direction or anti-clockwise direction? Let's solve this in clockwise direction. The second step here is, in this given circuit, which kind of Kirchoff's law are we going to use? Are we going to use Kirchoff's current law or Kirchoff's voltage law? Obviously, we are going to use Kirchoff's voltage law. So why are we using this? This is because this circuit has only one loop, and the same current which flows from this battery enters into 5 ohm resistor is the same current that will enter into 10 ohm resistor, because 10 ohm resistor and 5 ohm resistor are in series. There is no any other loop that this current I1 will split into 2 or more from here. No, we are going to use Kirchoff's voltage law. And remember, Kirchoff's voltage law says the potential drop or potential difference plus the electromotive force equals to 0. And the last step here is, I suggest for you to start making your equation from the battery. Now, in this battery, here is negative and here is positive. And we are going in a clockwise direction. So, we go in a clockwise direction and we end up in positive terminal of this battery. Then you just take the last sign. This would be plus 30 volt. We keep going. We come across a resistor. Leave the first sign. Take the last sign. Negative. This would be negative 5, but I1 enters into 5 ohm resistor. This would be negative 5 I1. And we're still going. We come across a 10 ohm resistor. This is the first sign and this is the last sign. Leave the first sign, take the last sign. This would be negative 10, but I1 enters into 10 ohm resistor. This would be negative 10 I1. And then we set this equation to be 0. Then we solve for I. Now this would be 30 volts equals to, then we take these two i's into the right side of the equality sign. This would be 5I1 plus 10I1. This would be 30 equals to 15I1. We are after I1. We divide both sides by 15. I1 would be the value of 30 by 15, which is 2 ampere. Very simple. Now, if someone wish to take this loop into anti-clockwise direction, are we going to obtain the same magnitude as I1 equals to 2 ampere? Of course, yes. Let's do it and see. Now, when we start here, then we're going to start from the battery. Now, this is the first sign of the battery, and this is the last sign of the battery. We take negative. This would be negative 30 volt. Then we keep moving. We come across a resistor. This is the first sign, and this is the last sign. Then we take positive 10I1. We keep going like this. Since we are moving anti-clockwise direction, we come across 5 ohm resistor. We leave the first sign, we take the last sign. This would be plus 5I1. Then we set the equation equals to 0. This would be negative 30 equals to, we take this to that side, negative 10I1, negative 5I1. This would be negative 30 equals to negative 15I1. And negative can go with negative. We are after I, we divide both sides by 15. By 15, I1 equals to 2 ampere. Just the same magnitude. The idea here is, when you take your loop, always don't consider the first sign. Any battery or resistor you come across, always take the last sign, following the loop you took. All right, now let's start to solve question number 1, and we're going to use the same idea here. The first idea is try to put the sign conventions. Always we know that the long terminal carries positive sign and the short terminal carries negative sign. And we know that current always flows from positive direction to negative direction. And here we have I1. And this I1 will obviously enters into 3 ohm resistor. And we know that it will enter from positive to negative. And still I1 will keep moving. When it comes to this node, I1 will split into 2. Why would I1 split into 2? Because we have resistor here and we have another resistor here. So definitely I1 will split into 2, I2 and I3. I2 will move in this direction and I3 will move in this direction. So now we are going to use 2 laws, Kirchoff's current law and Kirchoff's voltage law. Using Kirchoff's current law, this says I1 equals to I2 plus I3. Let's name this as equation 1. I1 is the summation of I2 and I3. Equation 1. Then the second step here is start with the first loop. Let's take clockwise direction. Using voltage law, which says KVl, the summation of the potential drop plus electromotive pulse equals to 0. So now we make our equation from this battery. And this battery starts from negative to positive. Then we just take the positive sign, positive 24 volt. And we keep going. We meet a resistor here. And this is the first sign. You neglect it and carry the last sign. That is negative 3. But I1 enters into this resistor, negative 3 I1. Then we keep going. This I1 split into 2. I2 goes this direction and I3 goes this direction. So I2 moves into 4 ohm resistor, but it starts from positive to negative. Then you leave the positive sign and take the negative sign. This would be negative 4, but now not I1, I2. Then we set this to be equals to 0. Now this would be 24 equals to, then we take this 2 into this side. It would be 3I1 plus 4I2. Let's name this as equation I2. So now we name this as equation 2. Then we go to the second loop. We also take it into clockwise direction because we took this one also in clockwise direction. Then we start from this, like this, and go like this, clockwise direction. This is the first sign. You neglect the first sign, then you take the last sign. This would be positive 4I2. Positive 4I2. Then we keep moving. It enters from positive to negative. And this is the first sign. We neglect the first sign, we carry the last sign. Negative 12, but I3 enters into 12 ohm resistor. Negative 12 I3. Then we set this to be 0. This is 4I2 minus 12I3 equals to 0. Let this to be equation 3. Then now substitute equation 1 into equation 2. Says 24 equals to 3I1 plus 4I2. Then now we are to substitute equation 1 I1 into this equation. This would be 24 equals to 3 into I1 is I2 plus I3. I2 plus I3. We close the bracket, then plus 4I2. 4I2. Then this would be 24 equals to 3 times I2. That is 3I2 plus 3 times I3. This would be 3I3, then plus 4I2. This would be 24 equals to 3I2, 4I2. This would be 7I2 plus 3I3. Let's rearrange this. This would be 7I2 plus 3I3 equals to 24. So let's name this as equation X. Then by elimination method, we can solve for equation. We have 7I2 plus 3I3 equals to 24 as equation X. And equation 3 says 4I2 minus 12I3 equals to 0. Let's find I2. Then to find I2, we cancel this I3. This is very simple. You multiply the second equation with 3 and multiply the first equation with 12. First equation times 12 and second equation times 3. So now here we will have 7 times 12. 7 multiplied by 12, which is 84. 84 I2, then plus 3 times 12. 3 multiplied by 12, which is 36. 36 I3 equals to 24 multiplied by 12. 24 multiplied by 12, and this is 288. 288. Then we multiply this 3 which hold this equation. This would be 3 times 4, that is 12 I2. Then 3 times negative 12, this would be negative 36 I3 equals to 3 times 0, which is 0. Now we add 84 I2 plus 12 I2. This will give us 96 I2. And this 36 I3, negative 36 I3, this will go with this. And this would be 288 plus 0 is 288. Then we divide both sides by 96 by 96. I2 would be 288 divided by 96. 288 divided by 96, which is 3 ampere. So by substituting I2 as 3 ampere into equation 3, we would have the equation as 4 into I2 is 3 minus 12 I3 equals to 0. Then 12 equals to 12 I3. Divide both side by 12, divide both side by 12. I3 equals to 12 by 12, which is 1 ampere. Then from the first equation, which says I1 equals to the summation of I2 and I3, then I1 would be I2 is 3 ampere, 3 ampere plus I3 is 1 ampere. Therefore,
So
I1
in this circuit also we don't
4
have sign conventions. Pause the video and try to put the sign convention by yourself. Okay, let's do it. In this battery, here is the short terminal and here is the long terminal. The long terminal we always assign the positive sign, and on the short terminal we put the negative sign. And the current always flows from positive sign to negative sign. Let's call this as I1. So now when this current keep moving, here is a node, and this current will split into two. I2 will go this direction and I3 will go this direction. I3. So now, then when I2 go into this direction, for it to enter into 4 ohm resistor, it will start from positive to negative. And when current is flowing like this to enter into this resistor, it will start from positive to negative also. And when this I3 keeps moving, here we come across a battery. This long terminal, we assign positive on it and this negative. And when I3 keeps moving, here is another resistor. It will start from positive to negative. So that's it. Now the second step is take a loop and go with your equation, which says I1 equals to I2 plus I3 as equation 1, and this is Kirchhoff's current law. Now start going through your loop. Here is a battery. The first sign is negative and the last sign is positive. Then take positive 12. Positive 12 volt. So we keep moving. I1 split from this direction and I2 goes directly into 4 ohm resistor. Then the sign here is positive and negative. Leave the first sign, take the last sign, and this would be negative 4I2. Then keep moving. Here we have positive and the last sign is negative. This would be negative 3I1. Then we set this to be equals to 0 as stated by Kirchhoff's voltage law. So now let's rearrange this. This would be positive I2 positive 3I1 equals to 12 volt. Let's take this as equation 2. From here we are done with loop 1, then we move to loop 2 in order to obtain the third equation. Let's start from the battery. The first sign is positive and the last sign is negative. Then we take negative 5 volt. And we keep moving. I3 is moving in this direction. We come across a resistor. This is positive and the last sign is negative. Then we take negative I3. Negative I3. Then we move in this direction. I2 enters into these 4 ohms. But the first sign here is negative and the last sign is positive since we are moving in this direction. Then we take positive 4i2. Then we set this to be equals to 0. Now let's rearrange this. We take this 2 to this side. This would be negative 2i would become positive 2i3. And positive 4i2 will become negative 4i2 equals to, this will remain negative 5. And let's take this as equation 3. So now here is equation 1. Then we can substitute equation 1 into equation 2. This would be 4i2 as this in equation 2 plus 3 into I1 is nothing but I2 plus I3. I2 plus I3. Then close the bracket, equals to 12 volt. 4I2 plus 3 times I2 is 3I2 plus 3 times I3 is 3I3 equals to 12 volt. Now this is 4 plus 3. This is 7I2 plus 3I3 equals to 12 volt. Let's take this as equation X. Then now we can eliminate equation X and 3 to obtain the value of I2 or I3. So let's bring these two equations down, equation 3 and equation X. Equation X is 7I2 plus 3I3 equals to 12, while equation 3 is negative 4I2 plus 2I3 equals to negative 5. So let's find the value of I2. To find the value of I2, we eliminate this. Multiply this by 2 as this, and you multiply this second equation by 3. So these two affect all the equation. This would be 2 times 7, that is 14I2 plus 2 times 3, that is 6I3 equals to 2 times 12, that is 24. And this 3 also affect all this. 3 times 4, that is negative 12I2 plus 2 times 3, that is 6I3 equals to 3 times negative 5, that is negative 15. So we are to find I2. Then we subtract. Now here we have negative 14, negative 12, which give us negative 26I2. And negative 6I3, positive 6I3 will give us plus 0I3, which is equals to negative 24 and negative 15. This would give us negative 39. Yeah. So here we have negative 26I2 equals to negative 39. And we divide both sides by negative 26 by negative 26. Negative go with negative, negative go with negative. I2 equals to 39 divided by 26, where I2 would be the value of 39 divided by 26, 1.5. I2 is 1.5 ampere. Then from equation 3, we can obtain I3 by substituting I2. Equation 3 says 2I3 minus 4I2 equals to negative 5. Then 2I3 minus 4 into I2 is 1.5. 1.5 equals to negative 5. 2I3 minus 4 times 1.5 will give us 4 multiplied by 1.5. This is 6 equals to negative 5. And 2I3 would be, when 6 go to the equality sign, when 6 moves to this, when 6 negative when negative 6 moves to the right side of the equality, it would be positive 6, then minus 5. Then 2I3 would be 1, and divided by 2, divided by 2. I3 would be a half, that is 0.5. 0.5 ampere. Then from the equation which says I1 equals to I2 plus I3, you can find the value of I1. I1 equals to I2 is 1.5 plus I3 is 0.5. Therefore, I1 equals to 2 ampere. Thanks for watching. Please don't forget to subscribe for more video updates. Science with Abdul.